Thank you all for being here. I'm Abdullah AlHamdan. I'll be presenting SandDriller, a fully automated approach for testing language-based JavaScript sandboxes. So as we all know, that JavaScript is widely used for programming, for software engineering, and building your applications. And for sure that those applications might be critical to security scenarios. Therefore, there's a lightweight solution for isolating those to provide JavaScript isolation in compare with hard or expensive isolation techniques, such as hardware isolation or even threads-based isolation. So JavaScript provides a cheap solution for some lightweight applications, starting from writing your smart contract or even having your IoT application or even doing malware analysis for JavaScript or even building your own application on the cloud. But unfortunately, those sandboxes are not tested in an automated way, or even there's no protocol to test those sandboxes. Before we start, we have to define what is JavaScript sandbox. Basically, the JavaScript sandbox limits the capabilities of third-party source code by limiting the access to the global object and the built-in functions. On top of that, to guarantee the functionality of the third-party source code, there is a way to share some references between the main program and the guest code, which is the third-party source code, by endowments. So as we can see here first, on the line number 4, we have the guest code hosted into or inside a sandbox, where the endowment allows to run specific built-in APIs or built-in functions via endowment by sharing those references. So I'm going to divide my presentation into two key points. The first key point is the study of language-based sandboxes. To start with this, we have studied the language-based sandboxes, and according to our findings, we have found that the sandbox must, first of all, isolate or prevent read-write outside the sandbox, and also it must restrict accessing privileged operations, and also it should prevent blocking the main program loop, for example, by DDoS attack or even algorithmic complexity and so on and so forth. And also it must be resistant to keep the main program alive by preventing the host process crash. The first key point of our study does not stop on this. I'm sorry for this complicated table, but please keep up with me. So the first thing, we have found that there are two classes of isolation techniques for JavaScript. The first one is runtime-based isolation. The other one is the language-based isolation. And also we have found that the language-based techniques can be used for both the client side and the server side. And also now you can figure out the danger or the attack surface, how it will be big if we have a vulnerable language-based sandbox. And also, the language-based sandbox basically is interested to cover the first two security objectives, which are preventing read and write out the sandbox, and also blocking to call powerful APIs from the outside of the sandbox. And there exist some researchers already. They did their own manual efforts to discover vulnerabilities into those language-based sandboxes. And unfortunately, for example, like safe eval, some vulnerabilities left open because they were not capable to change the design of the isolation. So according to the study that we performed, we studied those vulnerabilities, we studied the patterns, and we came across a very shared pattern between those vulnerabilities, that the threat is basically to escape the sandbox by accessing foreign references. To explain such attack, we will start with the host code, and for sure it's like having the global object with some powerful APIs. And we have our sandboxed guest code inside, and through the prototype chain, whenever we have a very successful implemented sandbox, it will block preventing it will block accessing outside the sandbox by preventing it to be inside. But whenever the attack was successful to reach foreign references, it will be catastrophic, since it will be able to escape accessing the global object and therefore can call very powerful APIs inside by creating the channel or the canal between the sandbox and the host code. So to automate the study and to study those attacks and also to perform the testing automatic way, we proposed our second key point of our paper, the SandDriller. It's the first approach for testing language-based sandboxes, and also it uses the dynamic analysis to test those sandboxes, and also it can be integrated during the development process of the language-based sandboxes. Therefore, we can have more robust isolation techniques. To explain our tool, we start with a seed code that can be any valid source code in JavaScript, and we put it into instrumentation and generation mode. The instrumentation injects oracles to check the oracles inside the seed code, and the generator will generate more variants according to specific criteria. And then we have several test cases. We run them on the sandbox where the aim is to look for those foreign references through the test oracles. And after that, we get the results and we see how strong or weak is that sandbox. Unfortunately, because of the limitation of the time, I'm gonna discuss the instrumentation process and some parts of the running the sandbox process. So the instrumentation basically injects test oracles to find all the foreign references inside that sandbox. That can be happen by adding analysis code into several points into the test program. For example, we start from global object and global variables. Maybe it can be also to test the function invocation, also testing the function entrances, and to guarantee that there is no communication through our analysis between the main program and the sandbox, we add our analysis on top of the seed program. So how we can verify that there is a foreign reference has been caught during our instrumentation? So we have our own Oracle checks. The Oracle checks basically, it's to target the read-write secret flag, which we injected it into our analysis code. Whenever this flag has been reached, it means that there is a read-write violation, which is targeting the first security objective. The second thing is to try to call powerful APIs, which is also targeting the second security objective. And on top of that, we also detect hard crashes, since we have noticed that some sandboxes are interested to tackle this problem. To test our approach, we call our HackerCat to implement our experimental results. So the first thing is that we have selected 3 different Node.js versions. We also selected 2 seed corpuses. The first one is ECMAScript test cases, and the other one is V8 engine test cases. So we can cover as much as we can from the language properties. And also, we run our test twice. The first one is with a variant generator, and the other one is without the variant generator. And also, we have selected a group of sandboxes which are covering the client side and the server side. As a result, we can see here that the amount or the number of security errors can be depend on the version of Node.js, which can be translated by saying that there are language properties, new language properties added to the newer versions of Node.js, which cannot be covered or might not be covered through those sandboxes. And also, the newer version of Node.js might be helpful to prevent those hard crashes, which might be hosting also those language-based sandboxes. And the very interesting part through this, by looking at this schedule, the stronger isolation mechanism giving more guarantees to have less threats like, for example, looking at secure ECMAScript sandbox, which providing like freezing the global object. It has less security threats in compare with safe eval that gives a different global object. We didn't stop on this. We have found several CVEs. We reported several CVEs, and I'm giving one example of them, which is targeting the Realms shim. This attack starts with rewriting, using or exploiting the dynamic of JavaScript by rewriting the prepare stack trace, using our function which has the injected prototype pollution. And we were able to call an undefined object that causes the error. Therefore, we were able to cause the error and call that rewrite function to write or escape the sandbox. We have communicated with the authors of this sandbox, and they have found that this is error by design. This is a vulnerability by design, so they have decided to deprecate this package. Last but not least, we have provided a study on language-based sandboxes, and we have figured out, or we have mentioned the security objectives of those language-based sandboxes, and we have proposed our methodology, and we came up with 9 CVEs, as we can see on the table reported to the owners. And I'm happy to let you look at our source code, which is available on GitHub, and also happy to communicate with me by email or asking me any question right now. Thank you all.